It's probably going to take me the majority of the hour to teach this lesson. Planning to, probably not tomorrow, but Wednesday, teach all of section 9.2, and then give you a work day for the chapter 9 assignment after that. So kind of like we did on chapter 8. So first, let's start with questions. In July of 2008, we had a poll that asked 1,783 registered voters nationwide whether they favored or opposed the death penalty for persons convicted of murder. 1,123 were in favor. Obtain a point estimate. When you see point estimate, what are you thinking? Yeah, it's a percent. Yeah, he had. For the proportion of registered voters nationwide who are in favor of the death penalty. So how do we find p hat? The x over n, yep. So 1,123 divided by 1783. And we get 0.6290. Okay, so then here's a question. Does that mean that most people favor the death penalty?
Most people
Yes,
survey,
over
like
50.
Most people in the survey. So would a different sample give me a different percentage? Yes. How confident are we in our estimate? That's a very important question. So we know that if we did this with a different sample, we'd probably get something different. So let's say there is variability in samples. Each sample will likely be different. So I can't just take my poll and say 62.98% of people are in favor of this. I could say 62.98% in my sample were in favor, but I can't say overall. So what we need is a range of values. We want to be able to say, I'm 95% confident that the real proportion lies between these two numbers. Okay, we can't pinpoint for sure. We cannot take our sample and say this is the exact percent for my population. But we should be able to create a range of values and say we're pretty confident the true value falls somewhere between these. That's called a confidence interval, and that's what we're going to be looking at. So our level of confidence is how confident we are. It will be a percent, less than 100%, so 90% confident, 80% confident, 99% confident. So how that works, a 95% level of confidence says that if I were to make 100 different confidence intervals from my sample, or from different samples, so if I took 100 different samples and found my confidence intervals, 95% of them would contain the true value. Okay, so it's how accurate is our data. So to find a confidence interval, it's our point estimate plus and minus some margin of error. So our 62.98, that was my point estimate. That's the middle. And then whatever my error is, you would add and subtract that to get your range of values. That margin of error tells us how accurate it is. So we're basically creating a window. The middle is our guess. And then we would get a range of values. The closer your guesses are, so it should be the same on both sides, so just not even. This one would have to be a lower confidence than this one. You know, so the bigger my window is, the more confident I am that the true value falls in there. If my window is really small, I'm less likely to include the true value. Big windows are more likely to have it. Okay, so our margin of error, how big that window is, depends on a few different things. Our level of confidence. So we know a bigger confidence level means we have to have more error. The sample size, we know bigger samples are more accurate. So if our sample is really small, we would have to have a pretty high margin of error. And standard deviation. The more spread out the data is, the less consistent. That would have to be a bigger interval. So those things all play into it when we're trying to decide. The things we know about p-hat, so we were using this on our quiz. If I say describe the sampling distribution, we always have our criteria. What are the criteria for p-hat? This is a review. One minus p. And the sample is less than 5% of the total population. What is the mean for p-hat? And what's the standard deviation for p-hat?
P. And then 1 minus P. Right.
Okay. Remember, this stuff's on your formula sheet. The criteria is really the only thing you have to memorize there. All right, I'm going to show you how to create a confidence interval by hand. Most of the time we are just going to rely on our calculator, but I want to show you both ways because I think it is helpful. You get a little more understanding when you're actually plugging things into the formula yourself. So, the formula to find our confidence interval. The lower number would be when you subtract, the upper number would be when you add. Z alpha over 2. So we'll talk about that alpha in a second. It has to do with our confidence level. The square root of p-hat times 1 minus p-hat over n. So it's kind of like that standard deviation built around the p-hat. That's what we're adding and subtracting. The meaning of a confidence interval. So if I ever ask you to explain, it's basically this sentence. We are whatever percent confident. The true value lies between the upper and lower limits. The margin of error is that Z alpha over 2 that we're adding. So let's make a confidence interval for that example we had. So this is the same scenario. I want a 90% confidence interval for the proportion of registered voters who are in favor. So we already found our p-hat. So from that first example, what was it, 0.6298, is that right? Okay, if I'm going to use this, we should verify our criteria. Would we assume 1,783 would be less than 5% of all registered voters? Yeah. I don't know the number of registered voters, but that would be less than 5%. My other one, my N, which is 1783, times P. Okay, what is my P? This one is a little bit tricky. So we're used to using the P given to us in the problem, right? The proportion. The 90% is only dealing with the confidence interval. So did I actually give you the P for the whole population? So we're going to use our p-hat here. greater than 10, so let's just verify it. And it's 415, so we're good. Okay. The Z alpha over 2 is probably the trickiest piece to this. Some of them, our formula sheet gives us, some of them we have to be able to figure out. So I want to make sure you guys understand. When we had Z alpha notation, remember at the very beginning in chapter 7, when we said Z alpha, we said alpha was the area to the table's area to the left, but when it gave us this notation, it was area to the right. What is my alpha here? We want 90% confidence, so that means 90% falls in the middle. All right, so if 90% is in the middle, we have 2%, 10% to split up over the two sides, right? And so that means, what is this total area to the left? That's 0.95. Okay, that's my total area. You have to find the Z that matches that, so that 95% is to the left. Okay, so remember when we're looking for the Z, we look inside the table for 0.95. So everybody do that. All right, the closest I can get to 0.95, I have 0.9495 and 0.9505, so it'd be right in the middle of those. So my Z is 1.645. Now you'll notice at the bottom, some of them are given to you. So for our confidence level, it tells us 90%, and what's it say for the critical value? 1.645. That only works though if I give you 90, 95, 98, 99. Okay, those won't be the only ones we find, so we need to understand how to read it from the table if I gave you a different percent. So you're trying to find your percent in the inside of the table and find the Z that matches it. So then, our confidence interval. I don't want to confuse them. I can either write these out separately or I can put them together. Do you guys, would it confuse you if I put plus and minus in here as I wrote it out? Okay. So if you look on your formula sheet, the very first bubble under chapter 9 or the first bullet, it tells us this formula, P hat. So our P hat is 0.6298 plus and minus Z alpha over 2, so 1.645, times the square root of P hat, 1 minus P hat, over N. Okay, so that's just straight from our formula sheet. So if I want to get my confidence interval, typically we just write it as like an interval starting and stopping point. You do the small one first. So we would do 0.6298 minus. We get 0.61098, so 0.611. And then for the upper, you just bring it up, back up and change your minus to a plus. We get 0.646.
I don't understand. You did the alpha. What's the
Alpha
so
over
basically
2.
what's the 1.645?
That's the Z. So we knew we needed 90% confidence. So we went 90% is in the middle, which means the area to the left has to be 95. So then we go to our table,
Yeah, I found
and we're
that.
finding that Z value that matches. So that's what the 1.645
So
is.
alpha over Z is what?
That's alpha over 2, sorry.
Oh, sorry. So what exactly does alpha mean?
Alpha in general is supposed to mean like area to the right, but basically in this case, it's just giving us our confidence interval. So it's coming from this, the 90% confidence. So we have 10% left over, that's where the over 2 comes in, because you put half of it on each side. So it's saying basically 5% is over here, so 95% is over there.
But it's instead of area to the right, it's area to the left.
Because the table, it has the area to the left. So that's why we look up the 95 instead of the 5. Yes, ma'am.
Can you look at my calculator, because I got the second one, but I didn't get the right first one.
Oh, okay. Oh, you did. I just rounded this up. Because
Oh,
if I were
okay.
going to 4 decimal places, I was going to round up.
That makes sense. That's,
You're good. Other questions? I did put a blank slide after this one if you need a little more space, but let's write a sentence what this means. So this was a 90% confidence interval. So we are 90% confident what were we finding here? The proportion of voters who favor the death penalty is between 0.6110 and 0.6486. Another way of thinking about it, if I got 100 different samples, I would expect 90% of those samples to give me a p-hat between those two numbers. If I wanted to up my percent, would my interval get bigger or smaller? If I want to be 95% confident. Where did I draw my picture? Remember, the more, oh, it wasn't on that slide. Where was it? Didn't I draw a picture at one point? Here. The higher confidence, it's got to get bigger. If I'm going to have 95% confidence, I'm going to need a wider range of values. Okay, if I want 99% confidence, it would have to get even bigger. So the higher your confidence level, the bigger your interval needs to be. All right. Let's get another one. A Gallup poll found 54.9% of those surveyed considered the amount of federal income tax they pay to be fair. Gallup reported the following survey methodology. Results are based on telephone interviews with a random sample of 1,016 national adults aged 18 and older. For results based on the total sample of national adults, one can say with 95% confidence that the maximum margin of sampling error is 4 percentage points. Right, that's really confusing, but if you actually look at any surveys, you'll see blurbs like that at the end. They'll talk about confidence intervals, they'll talk about margins of error. Determine and interpret the confidence interval. Remember, my confidence interval is a window based around my proportion. What proportion did they report? Okay, how much error did they say? 4%. So that means the true value could have been up to 4% above or below. So what would my lower limit be?
I need one.
It's based off,
0.9.
and the upper one would be 58.9. So that means 95% confident. So that's saying in 95% of my surveys, if I did it over and over again, I would get a value between these. So the proportion who believe the income tax is fair is between 50.9 and 58.9. So when you see those percents in a survey, it's not that exact number, it's actually a range of values. When they give you a margin of error, that's how much you would add or subtract from that. Yes?
Oh, so you just subtracted the, wait, how'd you get the 50.9 and 58?
It said it had 4, the error was 4.
Oh, so you just added, okay.
So error is, it's always like your p-hat plus and minus the error. So that's what we did there. Other questions? Let's do another one. A survey asked 800 16 to 17-year-olds in the U.S. if they had ever used their cell phone to text while driving. Of these, 272 indicated they have. Obtain a 95% confidence interval. So I'm going to need a lot of things before I can make my confidence interval. I need my p-hat. I need to check my criteria. How do we get p-hat?
I feel like that survey may be a little skewed.
Or the people lied.
That's what I mean,
Yeah.
skewed.
Yeah. So what criteria would we use? N, which was 800. P, what are we using for the P here? P hat, the 0.34, 1 minus 0.34. And that is most definitely bigger than 10. Is 200 or 800 less than 5% of the total population of 16 to 17-year-olds? Yeah, so criteria is good. We need this Z alpha over 2. Okay, so I know some of them are in the table, but not all of them, so I want to think about it. 95% confidence interval. That means 95% is in the middle. So we have 5% to split up over the 2 ends. So how much would be to the left?
97.5.
So you need to find the Z that matches 0.975. So you're looking inside your table. The closest we can get to 0.975, and that one is on there exactly. And the Z is? That's my Z. So then my confidence interval, you're just following your formula on your formula sheet. E hat plus or minus Z alpha over 2. So P hat minus P hat over N. So 0.34 plus or minus 1.96 square root of 3.34 minus 0.34 over 800. get these. So what that means is we are 95% confident the proportions of 16 to 17-year-olds who text while driving is between 0.3072 and 0.3728. So confidence interval, we're getting a range of values. Yeah,
Did I, never mind.
you sure?
Yeah.
So this isn't too bad to do by hand, but it is something our calculator can do for us as well. So I would like to show you how to use your calculator to get this. If I want to determine the effect of the margin of error by increasing the level from 95% to 99% on the previous example. So we already found the 95. If I were going to change it to 99%, it would just change my z, right? To do it on your calculator, you are going to go to Stat, Tests, Stat over to Test, and you want to scroll down until you get to letter A. It's called a one proportion Z interval. So Stat Test A. Is everybody there? My X. What was the X in this scenario?
217.
What is my N? My confidence level. We have to put this in as percent, so we just did 95, so let's do 99.99. And then you calculate.
Yeah.
That's a little fast.
Just a little bit.
Probably less room for error doing that long equation.
Yeah, we will.
So if
Use
it
the
can do that, you would think it'd be able to do what we were doing last week, or last.
Yeah, it's not doing it.
Let's check it. If you did, let's check how we did by hand. So if I go back to Stat Test, letter A, when we did it by hand, we did 95%. So if you did a 0.95 confidence level, did you get the same thing that we got when we did it by hand? I asked you to go back and do the 95% on the calculator and see if it matched what we did by hand. Yes. So, should get the same answer both ways. We were supposed to comment on the difference. So what happened to my interval when I went up to 99%? Yep. The wider interval, because it increased the error. So, in general, a higher percent will mean a wider interval. If I took it all the way down to 90%, what do you think would happen to my interval? It would get smaller.
So the smaller the percent chance you think it is, the smaller.
Yeah, so basically
That
think,
doesn't really make
Okay.
sense, because you'd think,
so if I said a 90% confidence, that just means if I got 100 samples, only 90 of them have to fall in this interval. Versus a 99% says, if I'm going to get 100 samples, 99 of them have to fall in this interval. So when you raise your percent, you have to have a bigger interval to encompass all of those, because we know all the samples will be a little bit different. If we are comfortable
and
with
the
a lot of
truth
them
is
not
that
being in it.
even all these are just projections and could not actually come to fruition, because it's not crazy that 90 of them wouldn't actually fit in.
Right, which is why you can't create 100% confidence interval, there's always like that error involved. Okay. All right. Let's look at this question. Find the point estimate of the population proportion. So point estimate, that's p hat. The margin of error of the confidence interval, errors E, and the number of individuals in the sample with the specified characteristic X. So I'm working backwards here. What I gave you was the confidence interval. So I'm saying, okay, let's pretend we have a confidence interval that goes from 0.051 to 0.074. My n is 1,120. Can you find these things from it? So, p hat is the middle. We know how confidence intervals are built. It's our guess, which is our p hat, plus and minus our error. So if we have these errors, we need to find p hat is the number in the middle. So to find the number in the middle, you add them up, divide by 2.
0.01.
I got, here's,
0.065.
might have dropped a decimal.
You subtract the
Error is how much you add or subtract to get to these. So just pick one of them. My lower limit is 0.051. I now know my p hat is 0.0625. The error is what I would subtract to get to 0.051. So to find the error, we can just do the point estimate minus my lower limit. And you get,
0.0115.
and that should be the same distance as from my point estimate to my upper limit. So if I subtracted 0.074 and my p hat, I get the same thing.
That's what
Yeah.
I found
The difference.
yeah.
X. Think about how p hat is found. P hat is x over n. I know my p hat. I know my n. So can you find x? P hat times 1,120 and x is 7.
So what's the middle one, E?
The error. It's the amount you add or subtract. So if you're thinking about this formula that we use,
Yeah, we did it in the last one, it was a couple of questions ago, it's 4 points of error.
yeah, this whole thing is used to calculate your error. All right, any questions on that? Okay, last thing we need to do, so I need everyone to take a look at this formula. It is a little bit uglier. So it is telling me how big my sample would have to be to get a certain estimate, to get a certain confidence interval. All right, so if I'm looking at this, n is the number I need in my sample. This is a fairly complicated looking expression. It just comes from taking that formula that we've been using and remanipulating it to solve for n. But just like everything else, do you think you have to memorize it? No, it's on your formula sheet. Everyone look at it, I want you to see. So in chapter 9, the second column, it says sample size. And this is that first bullet there. There's actually 2 different ones that can be used. One of them, if we have a p hat from a prior situation, and one of them if I don't know p hat. So if you read that little blurb, it tells you how what those formulas are. So let's take a look at this, and we're going to keep that formula sheet handy so we can look at that formula when we need to reference it. A sociologist wants to determine the percentage of residents in America that only speak English at home. What sample size should be obtained? So she is trying to figure out how big the sample has to be to get the data she needs. If she wishes her estimate to be within 3 percentage points, so what do you think that 3 represents?
E would be 3.
E. Okay, with 90% confidence, what's this helping me find?
Oh, the Z.
Yeah,
With the alpha.
the Z alpha over 2. Okay, is that one we've looked up 90% before, and that one is also on our formula sheet. What was it?
1.6.
Assuming she uses the estimate obtained from the census in 2000 of 82.4%, what would that be?
Yeah.
P hat. And we'll do a 0.824. So I have a P hat. That means I'm using the first formula. So it's N is P hat, 1 minus P hat, the alpha over 2 divided by E squared. So P hat 0.824. 1 minus 0.824. Z alpha over 2, so 1.645 divided by our error 3 squared. Now, we have an issue with this. What do you think we need to fix? One of our values is technically not correct. What's wrong with it? Can you find a mistake?
E.
3. So if you put this in right now, you're going to get a really weird value. Your error is in percent, so go ahead and change it to percent form when you plug it in. All right, so then if I put this in, this is the number of people that we need. So I get 436.04. All right. Can you have 0.04 of a person? If she surveys 436 people, would that be enough? No, you always round up here. So 436 wasn't enough, so you have to go with 437. That's how big the sample needs to be in order to be accurate within 3%. And last one. Find in if no prior estimate is used. So I'm going back and doing this again, but this time we're not going to use that census value. Okay, so it tells me if I don't have a prior estimate, N is 0.25, the alpha over 2 divided by E squared. 0.02 or 0.25. My Z alpha over 2 is still 1. What's my E?
0.02.
Okay.
Well, that one was almost easier,
It is easier.
so less information is better.
It's just less accurate technically in terms, you're gonna have to have more people in your sample if you use this one, but
This is a safer bet.
yep.
What was the last one?
750.
So this time, if we don't have a prior estimate, we're going to have to survey 752 people. All right. What questions do you guys have? Okay. There's a lot here, and I know I taught for a full hour, but we have a couple people